Good morning, everyone. Today we're going to be talking about another concept in statistics, namely variation. And what variation is it is a way to talk about how much data changes. So we're going to say roughly how much data changes, how much spread within a data set. So for example, let's say I've got two data sets that I made histograms of. Let's say I've got this data set on the left and this one on the right. You don't have to copy these down, this is just to illustrate it. Which one would you say, just looking at them, has more variation? Is it this blue one with just where all the values that fit into a measurement of 4, 5, or 6, and they're all clumped together? Or would you say that this one on the right varies more, where the values range from 1 to 8, and they sort of go steadily up and they go steadily down again in a symmetrical fashion? Which one do you think has more variation? If you guess the one that's red on the right, you're correct. It varies more. But that being said, there are three main ways that we talk about variation. They are one is the range, which we've spoken about in previous lessons. Another one is the MAD, or mean absolute deviation. And we're going to talk about that one today. And the other one is called standard deviation. We're not going to worry about standard deviation for now. I'm only telling you because it's one of the three main ways we talk about variation. At this time, pause this video, watch the other one that's attached to today's lesson, and then come back to it. Today, to talk about mean absolute deviation and variance in a sort of an almost real-world context, let's say I calculate the mean absolute deviation for my data set, and I get a mean absolute deviation of 1. Is that a big mean absolute deviation? Okay, the truth is we don't know. 1 what? Is it 1 inch, 1 yard, 1 year, 1 day? The truth is we're not really sure. We don't know 1 what just by hearing mean absolute deviation of 1. And another thing we need to know is, okay, what's being measured? So let's say we had ages in a 7th grade classroom. And we had a mean absolute deviation of 1 year. A mean absolute deviation of 1 year between the youngest person in class to the oldest person in class. They were all within 1 year of the mean age. That wouldn't be too surprising, because usually within a classroom, you're going to be pretty close to one another's age. Let's say, though, if we had shoe size. Let's say that I'm back at that shoe store scenario, and I ask 10 people what size shoe they have, and I get a mean absolute deviation of 1 size. Well, that's going to be pretty unlikely. In fact, there are only 2 scenarios I can think of where that would be likely to happen. If I ask 10 people randomly what shoe size they wear, and it just so happens that, say I'm standing outside of a store, and 10 people, all the same gender, from all the same family, walk by me, and they're the first 10 people I ask, then it wouldn't be too surprising if they all had the same shoe size, because they're all in the same family. There's probably some similarity between them. Another scenario, fictional, but forgive me for having a little fun with it. You know who these guys are? In Star Wars, there's something called the Clone Wars. and the main good guy fighters are all clones. So it wouldn't be too surprising if we asked 10 clones and they all had very close to the same shoe size because, well, physically, as you can see, they're pretty much all the same guy. So let's see, mean absolute deviation, height, shoe size. I believe that's all you're going to need for today's work. I'm sorry that I didn't make my own video for mean absolute deviation, but I watched that guy's trying to figure out a good way to explain it, and I went, dang it, he did too good a job. I can't do better than that. Oh, one more thing. I almost forgot. Another thing we need in mean absolute deviation, well, we don't need it, but it helps a lot. It helps if we have at least 2 data sets to compare. So let's say at the shoe store scenario. If I'm trying to figure out the mean absolute deviation of shoe sizes because I need to know just how spread out the shoe sizes are in this city where I'm selling shoes, and I get a mean absolute deviation of two sizes. Is that a lot for a mean absolute deviation? Off the top of my head, I'm probably going to say no. That being said, I don't know for sure. The thing that really tells me whether I've got a big mean absolute deviation or a small one is a comparison. So what I really need is a comparison either to a second data set within the same city, or even better yet, to a number of data sets with other cities, because I'm going, I don't know, somehow that mean absolute deviation, that doesn't seem like enough variability of shoe sizes. So let's say I look it up and I go, my store is in Los Angeles city, not county. And I look up Baton Rouge shoe sizes. And I find out that, oh, in Baton Rouge, there's a mean absolute deviation of 3, right? Well, that's not too big a difference. One size difference for my mean absolute deviation, that's definitely noticeable, but it's not huge. Now let's change it. Let's say they had a mean absolute deviation of 5. Well, that means one of a few things might be happening. One, maybe I need more data because their mean absolute deviation is way bigger. They've got more than twice as much variance as my data does. Or another possibility, maybe they coincidentally asked a number of people. So a number of people who happen to just have crazy different shoe sizes, or they might have included an outlier that they should have gotten rid of. So what I might need is a third city, or I might need to just do a second data analysis within my own city to figure out, okay, does Baton Rouge just have weirdly spread out shoe sizes? Or is something wrong with my data set? So if you have any questions during the assignment, let me know and I'll be there to help you. Have a terrific day.